Powering fashion, e-commerce with computer vision and deep learning. And we have Vishnu right here with us. Please put your hands together and welcome him on stage.
Okay. Good evening, everyone. We'll present some work that we are doing on fashion e-commerce at Myntra, particularly using techniques like computer vision and deep learning. I'll establish, let's say, the motivation for some of the work that we are doing. So as we know, fashion is a highly visual field in the sense all of fashion is interpreted based on how it looks and how does it look on you. And images are a rich source of information to capture some of this information, but at the same time, the information is highly subjective in the sense the way you interpret it will vary from, let's say, one person to the other. And it's more an art than a science. So in the sense, what would sell well, what would look good on you, and many of these are subject to decisions and a lot of like domain knowledge that, let's say, the designers use and the category managers use to input some of this information. So what we attempt to do in this work is see if we can interpret this information in a consistent manner. And we want to understand some of the fine-grained details that are there in the images. So I'll get to some of that in the presentation. And in doing so, we want to cover some of the important use cases at Myntra, including cataloging, purchasing, and personalization. So for example, can you make appropriate recommendations based on what the user is searching and so on. And we put to use the big fashion catalog that we have at Myntra, and we mine the information using some of the latest techniques such as deep learning and computer vision. So the brief outline of what I'm going to present. There are primarily two use cases that I'll talk of. One is on attribute extraction. I'll spend a good amount of time on that, and I'll also briefly touch upon some work that we are doing on auto visual quality check. To get to the details, there are primarily three problems that we are trying to solve in attribute extraction. One is the fine-grained attributes, things like color and so on, and then color is an important feature when you want to describe any of the fashion items. And we also spend a good amount of time inferring what is the graphic type that's printed on t-shirts. I'll get into some of those details as well. And the four key steps that we follow in the process. I'll touch upon a bit on the taxonomy because that's very critical to what we are doing, and then a bit on data preparation, and some pointers to deep learning. I'll not get into the details here. And some of the deployment scenarios that we looked at and the solutions that we made. So that's roughly an outline of, okay. As I mentioned, we want to get to, let's say, pretty fine-grained attributes that are there in the images. Let's look at this particular image, and if you were to describe it, so what is it that you would use to describe this particular image? So we want to say that there is a polo collar, and there is a logo on it, what is the sleeve length, what is the fit of the t-shirt, and what is the kind of stripe that's there on the t-shirt, and what is the length of the placket. And also a few more parameters like, let's say, what is the material of the item, which we can't do using vision. And also a few more parameters like body length and is there a rib, cuff, and so on. And so if you keep on describing it, there's too much of detail. And we try to get to, let's say, the maximum detail as possible. And in the process, we want to solve some of the use cases. So for example, in demand forecasting, particularly in the case of Rapid, which is a fast fashion platform at Myntra, we want to provide them with rich fashion-based insights. So for example, if you know that a particular color is trending well, or let's say a Pokemon Go is trending, can we give that information to Rapid team so that they can derive much more data-based insights? And then let's say we run out of a given product, what is it that we can replace it with? And also for product attribute clustering, for example, what are the common features among the top selling items at Myntra? And then also provide some options for the user to search, and also we can make recommendations. So for example, if a user is searching for a polo collar t-shirt, we'll probably show him polo collar t-shirts and so on. And another important use case is automatic cataloging. If you look at the cataloging, much of it is a manual process in the sense there is a photo shoot that happens and these images go to the cataloging team, they look at the images and then they tag what the collar is, what the pattern is, what the sleeve length is, so on. And all of it is a manual process. And by doing some of this work using deep learning and computer vision, we want to move from, let's say, manual entry of all these attributes to more of a quality check. Since they'll look at, let's say, all the values that are pre-filled by the machine and then do a quality check and then pass it through. So this will also help us in scaling faster and also saves us time and effort. So that's roughly the context of what we are doing. The first part in the exercise is defining what the taxonomy is. Because this is pretty critical to, let's say, describing any article type that we have. What we have done is we have taken, let's say, the current attributes that we tag in our catalog, and we got it reviewed by the designers. So in the sense, we have taken a designer-centric view to taxonomy generation, wherein we went and spoke to the designers that we have at Myntra, and then we came up with a list of attributes and also prioritized some of those that are important to them. For example, if a designer were to make a product on, let's say, Roadster, what are the parameters that they are interested in learning about? And we want to define a universal taxonomy, which will include sources such as, let's say, Flipkart and Jabong. And we want to go both the breadth as well as the depth. In the sense, we want to cover as many attributes as possible, and then we also want to define as many values as possible, and then be able to provide that information. And another important exercise that we did was there are multiple users for taxonomy at Myntra, including folks from the catalog, the designers, the storefront, and the category teams. And we signed up the taxonomy, and in the process, we also probably added a few more attributes that they are interested in, and also the values. And finally, we also want to map the taxonomy to terms that we can show to a customer on the Myntra platform. So that's roughly the exercise that we did. So let's get to, this is how, let's say, the taxonomy for a pocket would look like when I spoke to the designers. So in the ping that we have shown all the values that are possible for a pocket, but then we'll have to, let's say, split them into items that the machine can learn. For example, if you look at these values, they're not mutually exclusive. So we have to break them down into, let's say, chunks like pocket, how many number of pockets are there, and what is the type of pocket that is there. Is it a welt, flap, or a patch? And is a pocket of contrast? Does it have tipping? Is there a printed pattern on it? Is it a cut and sew, and so on? So thing is, we have to break them down into chunks that the machine can learn, and we also want to make some inferences based on rules. For example, if you know that there's no pocket, there's no need to, let's say, infer for the pocket type and let's say the pocket styling. So that's roughly the context of what we are talking about. So these are typical steps that we follow, which are common to any machine learning system. So the first step is we take the data in our catalog, and we took a decision to use all the data that we have in the catalog, because particularly for deep learning, the more the data, the better it is. And we took a decision saying, let's build a single attribute model for man, woman, kids, and flat shots. In a sense, otherwise we'll have to build individual models for each one of them, which is difficult to train as well as manage. And in certain cases, what we realized was the terminology between, let's say, the designers and the what is there in the catalog is different. Particularly in the case of stripes, the designers use terms like auto-feed or engineered, whereas what we show to the customer is classic and variegated. So we had to map these attributes across. And secondly, given that we have used all the data, the number and the values of these attributes themselves changed over a period of time. So we had to carefully map them to the same taxonomy. Otherwise, the machine will get confused. Since, for example, a crew neck is a round neck. So if you show crew and round as two separate entities to the deep learning or any machine learning system, you'll get confused. And one of the other challenges that we ran into is, for example, you look at this image, the model has folded up the sleeve, and if you were to ask a machine, probably it would identify it as a 3/4, whereas it's actually a long sleeve. Luckily, we are able to identify 70% of these cases when the fold is clearly visible. So there are also some challenges that we ran into. So going a bit into deep learning, I'll not get into the details, but essentially these are modern artificial neural networks, and what we are trying to do is we want to transform the input images to more global and more invariant set of features. And what is shown here in this presentation is an AlexNet, and there have been a revolution in deep learning since then in the last 4 years. The biggest advantage of deep learning is if you look at the current generation of algorithms, most learning algorithms, they don't scale beyond a certain point, even though you give it more data, because the kind of insights that you can draw from the data are limited, whereas deep learning can exploit all of them. And this is a pretty interesting quote from Andrew Ng, the chief scientist of Baidu. He says, data is rocket fuel and computing power is rocket engine. And we have a lot of data at Myntra to be able to build a very robust deep learning solutions. So let's look at one of the visualizations. In this case, we are trying to infer what the sleep type of the given image is. This is one of the convolutional neural networks. So for example, if you look at this particular image, this is where the activation is happening for a raglan sleeve. And it is also showing up here in the other convolutional layer. And in this particular image, we are trying to, let's say, learn the crop body length of the previous image. So essentially, if you look at it, this is how the network is able to visualize a crop. And this is at pool 1 of the GoogleNet. And if you go to pool 5, you'll get more abstracted. And this is how the neural network is learning the details about the image. So the next item that I'll talk on is dominant color extraction. As we know, color is an important attribute to describe any article type. There are a few challenges that we have to solve here. For example, if you look at this particular image, there is a rugged background. And for example, if you want to extract the color of the t-shirt, we have to get rid of, let's say, the trouser and also the skin and the hair pixels. That's one challenge that we have to do. And there are also varied backgrounds, as we saw in this case, and the poses could also vary. So ideally, the dominant color solution should be able to handle these. And but in the case of, let's say, a footwear item, we see that the background is typically plain. So we did some handcrafting to get rid of, let's say, the background, and then get to the footwear item, and then be able to extract out the colors out. So the next step that we do is we'll have to, let's say, represent these in a consistent manner. And Pantone is something that the designers internally use. Pantone is nothing but a set of color IDs that the designers use. There are about 2,000 odd of them. And finally, for the purpose of cataloging, we have to, let's say, group them and then show them onto the system. So there are two things that we have to do in dominant color extraction. What is the color space that we want to use? RGB is not a good choice for, let's say, any kind of color clustering, and we use LAB color space. And then we also use a distance metric to be able to group similar LAB values together. And the next step is to be actually able to cluster these various colors that we have, and we use a variant of k-means for this purpose. So let's look at some of the results that we have here. So for a footwear item, this is one of the colors that was identified. So we are doing pretty well here. And then this is the second color that was identified. And there are 3 more colors that are present in this particular item, and we're able to do well. And we also map them to the corresponding Pantone IDs, and then provide it as input to the designers as well as to the cataloging system. The next item is on graphic type identification. See, many of the printed t-shirts, they sell well or they don't sell well because of the graphic that is printed on the particular item. So, but then this is a hard problem to crack, because there can be a numerous number of graphics that are possible. I mean, whenever there's a new movie, probably there'll be new editions and so on. So the number of graphics are quite innumerable, and the size and placement of the graphics also vary. So for example, if you look at snapshot that I got from our catalog, you can see that the size and placement of them it varies quite a bit. And in certain cases, there are also multiple graphics onto a single item. For example, they can also put multiple Disney graphics all together onto the same t-shirt, and new ones are constantly being added. And so the deep learning system that we develop should be able to, let's say, generalize well even to the unseen graphics. And there are 2 technical challenges that we have to address. In the sense, it should be able to localize onto the graphic first. And the next step is it should be able to handle the within class variations and across class variations, and be able to identify the particular graphic quite well. So here are some results that we have based on the solution that we developed, the Captain America t-shirt, and we are doing quite well with, let's say, retrieving the images with the similar graphic being printed. And as you can see, there are few flat shots. and there's also a lady wearing an item, and it is not sensitive to gender. So we are able to localize to the graphic quite well, and also able to retrieve it based on Euclidean distance between the embeddings that we get. And this is another interesting result that we have, wherein we are able to identify Mickey Mouse quite well. And as you can see, there are multiple Mickey Mouses that are put onto this particular T-shirt, and even the variation of Mickey Mouse is quite a bit. For example, there is an M and a Mickey Mouse in the third image in the first row, and we are able to capture all of this quite well. Next item is we also wanted to, let's say, put a bounding box around the graphic, in the sense, as I said, the placement and the size of the graphic is also an important feature that the designers use, and we are doing quite well. All the bounding boxes that you see here are automatically generated by the deep learning model that we built, and there are a couple of attributes that we can derive from it, in the sense related to, let's say, the bounding box of the T-shirt. What is the coverage of the graphic? What is the placement of the graphic in the T-shirt? And is there a contrast between, let's say, the color of the T-shirt and the graphic being printed? And we did an evaluation wherein we compared the ground truth bounding boxes with what the machine identifies, and we are at a pretty good accuracy with respect to overlap. This is some work that we did on Marketplace, particularly looking at automatic visual quality check. I'll explain what the current process is. In the Marketplace cataloging, a set of images come from the vendor, and a couple of colleagues in the catalog team, they will download these images. They look at them, and then they want to get back to the vendor saying, there's an issue with the images that were uploaded. I'll get to some of these attributes shortly. And by building a system that will automatically analyze the images, what we intend to do is we want to give real-time feedback to these vendors, and we also want to be consistent with the results that we give. So these are some of the parameters that the catalog team was interested in. So the first one is blur, in the sense, is there a blur in the image? Color difference is, the vendor is saying the product is green in color, but then by our methods we identify that there is a blue, which means there is an inconsistency in the values that are reported. And we can also give this as input to, as feedback to the vendor. And there are a couple of pose-related parameters that they also look for. For example, is there a detail shot missing? Is there a look shot missing? And any of the left and right or back poses are the missing. And comments about the low resolution. So is the image of the given resolution? What is the size of the image, and so on? And is there a contrast between the background and the product? In the sense, this is more to do with the background, and also how is the quality of the background. So these are some of the checks that we do. And we do some of these by handcrafting, and for the pose part, we deep learn. So essentially, by deep learning, we are able to, let's say, identify all the poses, and we can go back to the vendor and say these are the poses that are missing. And one of the other use cases is by using the front, right, and left poses, we can also order them sequentially, because we want to put this data in a certain sequence in the app. So this is also something that we can enable with a solution such as this. So these are some of the images that I'm talking of. For example, the first one is a front pose, this is a left pose, this is a full length or a look shot, this is a back pose, and this is a close-up shot. So what is missing here is a flat shot, wherein we don't have a picture wherein the product is put on a table and then shot. That is missing. And yeah, and so we can give that feedback to the vendor. And what we have done is, instead of building, let's say, one model for jeans, trousers, and so on, we built a single model for all the bottom wear. Similarly, we have built one model for the top wear, and also for the footwear. In footwear, actually, the kind of poses that they use vary quite a bit. For example, if we take the case of flip-flops, a flip-flop type, depending upon the flip-flop type, the kind of poses that they use also vary. And then we did a union of all those poses and then trained a single model to identify the pose. The last part that I'll get into is deployment of some of the solutions that we built. So this is at a very high level. Essentially, what we want the client to send us image URLs, what is the article type, because the taxonomy varies and the models vary depending upon the article type, and also a unique number that will identify the product, and whether only specific attributes have to be fetched or all the attributes required. And then we return a JSON response along with the confidence values for the various attribute values. And we have built it as a standalone service, and it's a synchronous call, and we didn't couple it to the database because the client which is making the request should be able to get this data and then store it. And I mean, whenever there is a change in the model, the client should be notified. That's also something that we take care of, and we also cache some of the attribute values that are being returned. So this is roughly the data that is returned. So this is also a workflow. For example, image URL is being present. We figure out what is the optimal pose for that given attribute. For example, if you want to infer a print on the back, we have to use a back pose image. And similarly, if you want to pass the data to the color enricher, we have to segment out the t-shirt and then pass the data to the color enricher. And we return the array of all the possible values along with these, their confidences. And particularly in the case of colors, we return their Pantone IDs and what is the percentage of pixels that belong to the given color. And one of the things that we are also looking into is depending upon the load on the system, we can also do a GPU deployment of these solutions. Currently, we have deployed on a CPU. The advantage of the GPUs, we can send a batch of images and then get a response for all of them in one go. And to achieve a maximum throughput, we have done a parallel execution of different attribute extractors. For example, we can run for shirts, t-shirts, and kurtas in parallel. And in each one of these extractors can be deployed on multiple instances. So this is at a very high level, the kind of deployment that we have done. Yeah, thank you.
Any questions, ladies and gentlemen? Please put your hands up. We have a question here. 2 questions here.
So I have a speculative kind of a question. Myntra, we know, is at the forefront of fashion and lifestyle in India. So based on your deep experiences with understanding this specific category, you're understanding attributes much and much better, and virtually the kind of dictionary that gets built around it. So do you feel that in times to come, you can build some kind of a normalized language or specification that industry can start adopting, so that this this part of the category segment also becomes a bit more structured, because you kind of have the ability to start collating these attributes, standardize them, and also build a rich set of vocabulary that goes as values against it. So is that a distant possibility?
See, that's something that we are discussing internally at Myntra, but then I mean, if you go and talk to multiple designers, they have different view on attributes and the values. So that's one thing that we, I mean, I wouldn't call it a challenge, but that's a expected behavior in the sense. And similarly, when you look at, let's say, some of the players in the West, so they probably use a different taxonomy, and I mean, if you were to say where we are, we're at about, let's say, 60 to 70%, and the remaining 30% is something that we can add, and probably a glossary is something that we can build and publish. I think that'll be a nice thing to do. In fact, we have discussions going on at Myntra on that.
So let's say there is a product like smartwatch, and as a customer, I relate to it as a customer base, 70% of the customers relate it under, let's say, as a smart gadget, and 30% related to as, pure watch. So coming to the question, so does your taxonomy data model and AI mechanisms have capability to define affinity of a product to multiple nodes in a taxonomy?
See, one is the specifications of a given watch, which is one part, and the second one is the looks of it. See, the specific details that we can't infer from an image, obviously that's out of question. But then whatever we can infer from, let's say, a picture of the watch, I think that is something that we can definitely do. and probably along with, let's say, the specs, we could probably bring them together. In the sense, if we analyze, let's say, the text and the image together, probably I think we should be able to infer some of the details that would make sense to a user.
Any more questions? There's one question there. Yeah.
Yeah. Here. I was wondering that is there any feedback loop built in? So when you get an attribute wrong, right? How do you get to know? How soon do you get to know, right? Do you look at implicit user interactions, etc.? That when you list something under wrong attribute, the user stop interacting with it.
See, we want to do it more at a catalog system, because as I mentioned in one of the slides, the attributes that we are populating will go into Dexter, which is the internal Myntra tool, and somebody will look at the data and then correct the mistakes that we made, and we'll have a feedback loop from the Dexter system to our solution. In the sense, we want to have logs of all the changes that are made so that we can use it to improve our models. So that's already being done.
Okay, thank you.
Any more questions? That's it, I think. Thank you, sir. Thank you so much.